All right, so we're going to start with problem number 9, and then we're going to go do problem number 11. All right. First thing that we're going to do is fill in our first statement. That would be our given information. So line J is parallel to line K because that was given. It gives me the next two statements, and it only has room for one final statement. What goes down here? Angle 1 and angle 6 are supplementary. All right, so let's figure out why we can make these statements. We know that these two lines are parallel because that was my given information. The next statement they make is that angle 1 and angle 5 are congruent. What kind of angles are angle 1 and angle 5? They're corresponding angles, yes. And when the lines are parallel, my corresponding angles are congruent. That is the corresponding angles theorem. This seems like a really good time to pause for just a second and talk about when I use something like the corresponding angles theorem versus when I use the corresponding angles converse. So when do I use the theorem? When do I use the converse? If I start by knowing that the lines are parallel and I want to use that to say the angles are congruent, that's my corresponding angles theorem. The converse would be if I start by knowing the angles are congruent and I want to use that to be able to say that means the lines are parallel. So when I take my if-then and I switch it around, when I change what I know at the beginning, that's when I use the converse. So if I know the lines are parallel, I'm just using the theorem. If I want to end by saying the lines are parallel, that's when I use the converse. All right, so my corresponding angles theorem is getting used here. And then it says that angle 5 and 6 are supplementary. Well, here's angle 5. Here's angle 6. What kind of angles are 5 and 6? What do we call that pair? That is a linear pair. Linear pair angles. And they are supplementary. What tells me that they're supplementary? What can I use to be able to claim that they are supplementary? Linear pair theorem. All right, now we are to our last reason. And I noticed that the statement right here, the next to last statement, looks a lot like my very last statement. Substitution. We're going to take angle 5 out. We're going to put angle 1 in its place, which I can do because I know they are congruent. So that is substitution. This is a situation where it would not be transitive property. I would have to use substitution here. To use transitive property, you either have to have equals signs or you have to have congruent signs. So if you don't have an equal sign or a congruent sign, it's not possible for it to be transitive property. Right, number 11 was the next one that I was asked about. So let's go look at that one. And number 11 is a lot like the very first problem that we had on the skills check yesterday. So there was something that I noticed on quite a few of the skills checks yesterday. And that is whatever the given line was, that's what I was getting back as a graph. You can graph this line. I won't take off points if you graph that line, but it doesn't give you any points either because that's not the line that I want to see graphed. The only reason that you are given this line is so you can identify the slope. We don't care what the y-intercept is. It does not matter. The only thing we need from that given line equation is the slope. Because then we're going to come down and we're going to graph a line that is parallel to that. What do we know about slopes for parallel lines? They are the same. Same slope. So my parallel slope is 1/3. I can't use that yet, though. If you were to graph the given line, you would start by graphing your y-intercept, but we don't want the given line. So I have to use the point that they gave me, this point right here. You graph this first. So I'm going to go put a point down at -4, 2. Remember, the first number in an ordered pair tells you the left, right. So this is telling me that from the origin, from 0, 0, we're going to go to the left 4. The second number tells you the up, down. So I'm going to go left 4 and up 2 to plot my first point. After I get my point graphed, that's where I'll come in and use the slope. What is slope? Rise over run. So this top number is my rise. The bottom number is my run. Since the rise is positive, we're going to go which way, up or down? Up. The run is positive. Do I go left or right? Right. So from that point that I plotted, I'm going to go up 1 and right 3. 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 And I can even back it up and do everything in reverse. Down 1 and left 3. Once I have my points plotted, I'm going to grab a straight edge and I'm going to go through all of those points. So there's my parallel line. All right, so that is part A. Part B, we're going to graph the perpendicular line. I still need the slope from that given line. Only what do I need to do to the slope? Yep, opposite sign and flip it. Well, my original slope from up here was a positive number. So my perpendicular slope will be what type of number? It's going to be a negative. Instead of 1 over 3, we flip it over, and it's going to be 3 over 1. Just like before, we have to graph the point first. So I'm going to graph the point at 1, 6, right 1 and up 6, right here. How many negative signs does this slope have? 1. You have to choose whether you're going to put that one negative sign with the numerator or with the denominator, but they're not both negative. The negative has to go with just one of those numbers because we only have one negative number. If they were both negative? If they were both negative, yes, it would change. No, it does not matter which one of these you decide to be your negative number, whether you put it with the 3 or the 1. I'm going to put it with the 3. This is still my rise, only because it's a negative. That means I'm going to go which way? Down. My run is a positive number, so we're going to go which way with the run? To the right. If I had decided to put the negative with the denominator, with the 1 instead, my rise would be positive, so that would be up, and my 1 would be negative, which would mean left for my run. So that's the exact reverse of what we have here. That's like when we take points and go backwards. All right, so from my given point, from that black dot, I'm going to go down 3 and to the right 1, down 3 and right 1, down 3 and right 1, down 3 and right 1. I can get one more on there if I go just past the graph. I can't really back it up. I have to go off the graph to back it up, but I could put it up there if I wanted to. I know about where it's going to fall. And then I grab my straight edge, and I go through all of those points that we just plotted. That is for my perpendicular line. So remember, that given line, that is not what I'm asking you to graph. The only part of the given line you need is the slope. You can cross everything else about it out. What else would you guys like to see? Yes. 14? Absolutely. 14 is the next to last problem. We're going to name our pairs of angles, if possible. And then we're going to describe their relationship. Are they congruent or are they supplementary? Are my lines parallel here? Yes. How do we know? They got those little arrows on them. So line L is parallel to line M, because they each have one little arrowhead on them. And line S is parallel to line T. They each have little arrowhead on them. All right. So one pair at a time. First, we're going to look at angles 10 and 11. 10 is here. 11 is here. What is the line that they both touch? They both touch M. Neither one of them touch L, so I don't need to look at that at all. Tomorrow when you're doing the test, if you want to be able to block out one of these lines because it's too much going on in the picture, I will happily give you Post-it notes so you don't have to scratch things out. You could use the Post-it notes to cover stuff up. Just let me know when you're taking your test if that's something that you want. All right, so I have angles 10 and 11. They both touch line M. My two lines are S and T. M is my transversal. They're interior. Same side or opposite side of M? Same side of M. What do we call them then? Consecutive interior angles, yes. Are consecutive interior angles congruent or supplementary? Supplementary, yes. All right, let's do the next angle pair. This time we're looking at angles 6 and 14. 6 is right here. 14 is right here. They both touch S, yes. So I can scratch out T. I don't need to look at this one at all. They both touch S. L and M are my parallel lines. Are these both interior angles? Are they both exterior angles? No. 6 is interior. 14 is exterior. If I have one interior and one exterior, then I need to check for matching corners. Are they in matching corners? What do we call matching corner angles? Corresponding angles. Are corresponding angles congruent or supplementary? Congruent. Matching corners are congruent when the lines are parallel. All right, number 3, we have angle 16 and angle 3. Here's 16. Here's 3. What do they both touch? They both touch T, so I don't care about looking at S at all. That means my parallel lines are L and M. Are these both interior angles? Are they both exterior angles? Yes. Same or opposite sides of their transversal T? Opposite. We've got one that's on the left of T and one that's on the right of T. What do we call them when they're exterior angles that are on opposite sides of the transversal? Alternate exterior angles. Congruent or supplementary? Congruent. The alternates are congruent. If they're alternate interior or alternate exterior, they are congruent. The consecutives are my supplementary ones. All right, angle 15 and angle 11. Here's 15, here's 11. What line do they both touch? They both touch M, so I don't need to look at L. Is that the only line that they both touch? They both touch T also, so I don't need this line either. They both touch 2 of the same lines. They're a linear pair, yes. If they both touch 2 lines in common, then they're either a linear pair or they're vertical angles. In this case, these are a linear pair. Are linear pair angles congruent or supplementary? Supplementary. All right, 3 and 16. Here's 3. Here's 16. What line do they both touch? T. Are there any other lines that they both touch at the same time? Nope, just T. It would be just like C. C had 16 and 3. Here we just flipped it around the other way. So these are alternate exterior angles. Which are congruent. We haven't done 6 and 9 yet, though. 6 is here. 9 is here. What line do they both touch? They both touch S. Do they both touch any other lines together at the same time? No. Interior or exterior angles? Interior. Same side or opposite sides of the line they both touch? Opposite. 6 is on the right side of S, 9 is on the left side of S. So what do we call these? Alternate interior angles. Are alternate interior angles congruent or supplementary? Congruent. All right, last one. We have angles 4 and 7. What line do they both touch? They both touch T. And which one? And they both touch L. They both touch the same 2 lines. That means it's either a linear pair or it's vertical angles. These are vertical. They are non-adjacent, formed by 2 intersecting lines, vertical angles. Are vertical angles congruent or supplementary? These are congruent. I need you to get your review out, please. You with me?
We're missing someone.
Getting there. Yes. What else would you guys like to see? Number 2? Absolutely. Go all the way back to the front page and look at number 2. Yes. You gotta stay awake though. All right. So we know that line P is parallel to line Q, and line M is parallel to line N. You're welcome. So these 2 are parallel, and these 2 are parallel. We also know that angle 16 is 74 degrees. Angle 16 is right here. That angle is 74 degrees. What other angle up here would have to be 74 degrees? 14 has to be the same size because those are vertical angles. Which one? 6. Let me see how we can get there. Yep. Before I can talk about 6, though, I got to talk about a different one because 16 and 6 don't have anything in common. 3 is not congruent to 16. Look over here with me. Find an angle over here that's also 74. 4. Those are corresponding. Now I could say 6 because 4 and 6 are alternate interior. What other angles have to be 74 degrees? 8 and 2. There's 2 more. 12 and 10. All right, I think we're ready to answer these questions now. All of those angles that I have marked are 74 degrees. Is angle 11 one of the marked angles? No. So how am I going to find its size then? 180 minus 74. What is 180 minus 74? (180 minus 74), 106. How big is angle 4? 74. Angle 8? 74. Angle 3? 106. Could we have done this if the lines weren't parallel? Nope. The lines have to be parallel for me to make these relationships between lines. What else would you guys like to see? Number 7? Absolutely. Soon. Oh, I'm sorry. Number 7, use the given information to determine which lines must be parallel. All right, so the first thing they have is angle 2, this one here, is congruent to angle 6. What line do they both touch? They both touch C, so I don't need to look at this at all. So what would the two parallel lines have to be? A and B. All right, the next two angles that it gives me are 8 and 9, these two right here. What line do they both touch? They both touch D. So I don't need to look at this at all. What are the two lines that would have to be parallel then? A and B. All right. 7 and 9. Here's 9, here's 7. What line do they both touch? D. So I don't need this. What lines would have to be parallel? A and B. And then we have angle 1 and angle 8. What line do they both touch? They both touch A, so I don't need this one at all. So C and D would have to be parallel. What else would you guys like to do? You want to do 8 while we're here? Did you have another one you wanted to see? Number 8 sounds perfect. All right, so all of these are done in relation to angle 1. So everything is being done in relation to angle 1. Which angle is a vertical angle with angle 1? 4. There are 2 answers for this next one. Which 2 angles form linear pairs with angle 1? Angle 2, but not angle 4. Angle 4 is a vertical angle. Angle 2 and angle 3, yes. Turn around, please. What is corresponding to angle 1? I need matching corners. 5. Remember, corresponding is matching corners. Alternate exterior angle. 8. Remember, this is all in relationship to angle 1. So 1 and 8. Consecutive exterior.
7.
Angle 7. What's the only angle that we didn't use? Angle 6. We've got about 13 minutes left. That's enough time for, depending on the length of the question, all 1 to 3 more questions. 13 sounds good. You guys had one like this on the skills check yesterday. We're going to write 2 equations, both of them in slope-intercept form, for lines that are parallel and perpendicular to this given line. What's the only thing I need from that given line? 4 over 3. The slope is the only thing I want. I don't care about any of the rest of that line. So I'm going to split my page down the middle. We're going to do parallel on one side. And we're going to do perpendicular on the other side. What's the important thing I need to know about parallel? They have the same slope. So over here on the parallel side, I know that I want my parallel slope to be what? 4/3. What's the important thing I need to know about perpendicular? They have different slopes. Different in what way? Yes, Desire. It's reciprocal and it's flipped. That is reciprocal. There's one other thing. Yes, opposite signs. Opposite sign of the original line and reciprocal. So we're going to flip the fraction. So what will my perpendicular slope be then? -3/4. Perfect. They gave us this ordered pair right here. Our lines have to go through that. So they're giving me an X and a Y. That means we need to use point slope form. Y minus Y1 equals M, and then parentheses X minus X1. When we know what we want our slope to be, and they've given us a point, we have to use point slope form. We're going to do that for both of these. So I have Y minus, what am I going to put in for Y1? 10. So Y minus 10 equals, in for M, I'm going to put the slope that I want. So I need my parallel slope when I'm over on the parallel side. What goes in for M? 4/3. And then parentheses X minus, what goes in for X1? -24. Be careful, he gets another set of parentheses because I've got a negative and a negative together. What happens where I have this negative and negative? Turns to a positive. So Y minus 10 equals 4/3, and then parentheses X plus 24. Is that in slope-intercept form? No. What do I need to do to get it there? No. Have to distribute first. And the distributing has to happen to both of the numbers. One of the things I noticed on the skills check is some people are distributing to the X, but they're not distributing to that second number. That does change your answer, and it does make a difference. So Y minus 10 equals 4/3X. And then what's 4/3 times 24? 4/3 times 24. 32. Now I do what? Now we add 10 to both sides. And that means my parallel line is Y equals 4/3X plus 42. My perpendicular line is almost the exact same process, except it's right at the beginning when I'm substituting in that I have to put in the slope that I want. I cannot put the parallel slope in here and then just change it at the end. I can hit myself in the face with my pen though. You have to put the correct slope into the formula. You can't just change it at the end. Yes, thankfully. So I have Y minus, we're still putting 10 in for Y1, equals, what are we putting in for M this time? -3/4. That's where that perpendicular slope goes. And then parentheses X minus, and we're putting -24 in the place of x1. And what happens right here? Becomes a positive. So y minus 10 equals negative 3 over 4 parentheses x plus 24. Now what do I need to do? Distribute. Take that negative 3/4 and multiply both of these pieces by that. So that would be y minus 10 equals negative 3/4 x. Negative 3/4 times 24 is what? That was 4 over 3 times 24. I have negative 3 over 4 times 24. Negative 3 over 4 times 24. I need you to stay with me. What is it?
How does the 2 cancel out?
It's negative 18.
Negative 18. What do you mean, how does the 2 cancel out? For the slope? We're not canceling anything. We're taking like 4/3 times 24 here.
Yeah, like the negative 2.
Oh, 2 negatives. When you subtract a negative number, that is a positive number. Yeah. All right, we're almost there. This is almost slope-intercept form. What else do I need to do? Add 10 to both sides. What's negative 18 plus 10? Negative 8. So y equals negative 3 over 4x minus 8. When they give you a point and you know what you want your slope to be, you plug those pieces into point-slope form. What'd you say? Well, it just showed up on the skills check yesterday, so what do you think? I think it's probably highly likely that there would be a problem like this.
What was the y-intercept on this one?
Positive 7.
That was so
We only have about 4 more minutes until the bell, which is not really enough time to go through any more questions. However, please stay in your seats. I do want to show you guys where the answer key is. Go. All right. So from our Canvas homepage, from right here, if you want the answer key for the test review, you need to click on Modules. You're going to scroll down until you see Module 3B. You're going to continue down to the bottom of that module until you see today's date, Tuesday, 10/1. Review for Module 3B, Test Day 2. That's what you will click on. Once you are in here, you're going to scroll down. All of the videos from today will be in here. I only have one up right now. I've got 2 more that are ready to go up, and then 7th period will go up after this class. Scroll all the way to the very, very, very bottom, right down here, the Module 3B Test Review key. If you click on that, it will pull up all of these problems, completely worked out. We're going to be turning in your test review, and I grade it for completion. You have access to all of the answers. There is no reason why you should not be able to complete the test review.